Good morning, everybody. We are on day 6 of NTI, and this has been 10 days since the sadness began. I kind of miss you guys. It's no fun being in this classroom and not getting to talk to you all and cut up and actually work with you rather than trying to do the best we can via video. I do want to ask a favor of many of you because there is a small core group of you that I've heard from on a regular basis, participated in the Zoom classes, and then there's a majority of you, though, that I have not heard from or have not participated in the Zoom classes. So please, at the very least, shoot me a message and let me know you're doing okay. Let me know that you're watching the videos. Just do something, though, so that I know that everybody is involved, because we have a week on our homework assignments, and so I may not hear from some of you. You may look at the video and you start working on the homework, and then I never hear from you for a week until you submit it, because maybe you get it. But I just want to know how everybody's doing. So please, there's 23 of you in this class. I'd like to get 23 messages today or something to know that you all are okay. As you're probably aware, we're going to be doing this now until at least April the 20th. To the best of my understanding, there will be a spring break week put in there. I don't know how exactly that's going to play out, but congratulations. Get a spring break finally, and we're in the midst of a global pandemic, so enjoy that. I don't know what you'll do, but hey, got a spring break for what it's worth. As far as this class goes, I think maybe a lot of you are starting to figure out that we have periods where the difficulty of the content kind of ebbs and flows. We'll hit this point where there's a lot of really new concepts to grasp and understand, and you work really hard at it, and you break through, and then the remaining part of that section or the next couple sets of notes are really relatively easy, and then it ramps back up. So here with the normality and the normal distributions and things like that, I think we're finding that it's not too difficult, but it's all predicated on understanding everything that came before it. And then what we're going to look at today is no different. This is kind of the downhill slide of the easy stuff. We're going to start approaching that hill again, where it's going to get a little bit more challenging. We're going to have to introduce some more mathematics to understand where we're going when we start talking about sampling errors, which is getting ready to come up. So enjoy this. Things may get a little bit more challenging, but then again, right after that, it should be relatively simple again. I am proud of you guys for how well you're doing in this class and for how hard you're working on it. I'd be more proud if I knew that everybody was okay. So again, please send me something to let me know you're doing all right. We will have 2 Zoom class meetings this week. I would like to plan on them probably being, maybe Wednesday, Friday, or Tuesday, Thursday. So watch this video, I'm hoping today, Monday, March the 23rd. I don't know what day it is. And let me know, pick 2 days and tell me what times work best for you. I'd like to hear that from everybody. I'll put together the best 2 days and the best 2 times, and that's what we'll go with. Like I said, I know many of you have jobs. I don't know what your work schedules are. Many of you have developed extraordinarily irregular sleeping patterns, and I may have to interfere with those. I'm not sure, but I just hope everybody's doing well. So what we're looking at today is assessing normality. And sometimes when we work with normally distributed variables, it's easy to see, hey, this variable is obviously normally distributed. Sometimes, though, it's hard to determine that when we're just looking at sample observations of the data. We're kind of just picking and choosing this small sample or cluster of data from a larger set. Can we determine whether or not that data is normally distributed based off that small sample? And what we want to do is we would take that small set of data, the small sample, and we would plot it, just those points. If it is approximately linear, then we know that the data set itself is normal or approximately normal. If it's not linear, then we can't say with any certainty that it may be normal. It could be we've picked an unusual sample set. But if it is a small sample and it is linear when we model it, then we can say that it is normal. And what we will do to evaluate that is use a normal table. And I'm going to show you that. It's on the end of this set of notes. This time I actually did include the table in the set of notes. So we're going to kind of go back and forth. There's only 2 examples on this video. So right here in the red, it says to assess the normality of a variable using sample data, you want to construct a normal probability plot. If the plot, this is bullet point 1, if the plot is roughly linear, then you can assume that the variable itself is approximately normally distributed. If the plot is not roughly linear, then you can assume that the variable is not approximately normally distributed. These are very loose guidelines for small sample sets. However, if it's a large sample set, then you want to really kind of adhere to these guidelines. So we will use a normal table. It's referred to as table 3. Here in the notes you can see that. Let me highlight it for you so you can see where I'm at. Right here, well, my pen's not working. There we go. Right here, table 3, it's the end of the notes. It gives normal scores for sample sizes from 5 to 30. So anything over 30, this table is not going to be useful to you, and that would be what we would consider to be a relatively large sample set. So relatively small sample sets would be anything between 5 and 30. So for example 1, it says the IRS publishes data on federal income tax returns in a publication called The Statistics of Income, Individualized Income Tax Returns. A simple random sample of 12 returns from last year revealed the adjusted gross incomes in thousands of dollars that are presented in this table here on example 1. Construct a normal probability plot for these data. Use the plot to assess the normality of the adjusted gross incomes. So here Google Sheets is going to again be your friend. We're going to use Google Sheets pretty much exclusively in this set of notes. So for example 1, you have the table of values, and I have already entered those into Google Sheets, and I've added a couple other things as well. But right here in column B, this is what I want you to look at. There's the adjusted gross income. I typed in the values, and then what I did is after I typed them in is I highlighted all the numeric values, right-clicked on it, sorted the range A to Z because I wanted it to go from smallest to largest. Over here in the first column, I made a column that I just called data point, and I numbered them in order 1 through 12. We had 12 data points. They're numbered 1 through 12. I'm going to use these first 2 columns to assess the linearity of the data, and then this column C, I'm going to show you where that comes from here in just a second. So first we want to highlight the 2 columns and their headers, data point and adjusted gross income, and we want to highlight the values. We're going to create a chart, and rather than a line chart, I want to use a scatter plot. Okay, so there is the adjusted gross income versus data point number, and we want to determine whether or not this appears to be linear. Now it does have somewhat of maybe exponential curve to it, could even be logarithmic, but if you go to customize and then go to series and do a trend line, now everything will have a trend line, but with this one, the particular trend line, you can see how these data points do seem to be kind of clustered above and below that line, and now we can actually kind of say that this does appear to be a linear set of data. Because it is a linear set of data, we now know that it also would be normally distributed. So we can delete this chart. That was just a check to make sure that it was normally distributed. Now we're going to go back to our notes, and this is where I want you guys to go to the last, let's see, what is it, page 4. Page 4 and 5 has the table 3 that I referred to. These are your normal values. What you want to look at is the header row for each table. It has, in this first one, 5 through 13, and then the next one is 14 through 22, and then on the next page it's 23 through 30. What we're interested in are these header values. These are the numbers of samples in your set. The sample that we happen to be working with is of size 12, So if we look at column 12, there are normal values. That is the order that those normal z-scores should appear in our table. Like I said, we're just normalizing this without actually doing a whole lot of computation. So 12 samples, there's the normal values. You can see that it's symmetric, negative 1.64 up through negative 0.10, and then we have the opposites of those values, 0.10 and so on up to 1.64. So we would just transfer those numbers to our chart right here, and you can see I've already done that in the column that I called normal score. So we have negative 1.64 down through 1.64. So once you enter these normal score values, you have the normalized values for each data point on the adjusted gross income, and that's all you have to do. Again, it's not too difficult. When we look at the next example, we are just simply looking at outliers that might be presented in the data. So remember, we've talked about outliers before. It's data points that fall well outside the overall pattern of the given data. And with example 2, I went ahead and I plotted two different plots here for us. But we're looking at the example where we have the U.S. Department of Agriculture publishes data on U.S. chicken consumption in the publication Food Consumption Prices and Expenditures. The annual chicken consumption in pounds for 17 randomly selected people is given. A normal probability plot is provided as well. We're going to use the plot to discuss the distribution of chicken consumption and to detect any outliers. So the plot that you see on the left, I did exactly the same steps that we did in example 1. I plotted all the values with their normal scores in this case. And you can see down the horizontal axis we have pounds of chicken. With the vertical axis we have the normal score. And we can look at that and we can see this data point right here definitely appears to be an outlier because the trend kind of follows this orange line that I've drawn on the screen here. So we want to possibly eliminate that value, and you can see it's 0.0, data point 0 right here. That person could have been a vegetarian. It could have been a recording error on the part of whoever created the table. But there could be any number of factors, but given the particular set of data, the sample that we're looking at, that 0 is certainly an outlier. So then the graph that's on the right side of your screen is the same data, but I have removed the outlier point, and now you can see that this line, there's no points that appear to be extreme outliers relative to that line. That is the end of this set of notes. Normal table values are given, and you've just got a few questions here. Let's see, 4 questions. Yes, I know, A, B, and C. Oh gosh. Create a normal probability plot. We've done that. Identify any outliers, and then just talk about whether or not it appears to be normal. So, I mean, I know it says it has 3 parts, but they're not going to be that difficult. And on the part B on each one of them where it says to identify any outliers, if you would like, you can remove any outliers and replot the data just to kind of see it a little bit better. Actually, I would encourage it, but that's all we've got. So, again, I hope everybody's doing well. Please check in with me today. And then, like I said, also make sure that you all get back to me about Tuesday, Thursday, or Wednesday, Friday for Zoom classes. So I'll be talking to everybody soon.